Hey, Travis, you may want to mute because we can hear your breathing.
Oh, it was muted prior, so I don't know why it unmuted itself.
Oh, I think every time you log into a new room, it mutes or unmutes. I'm sorry.
Oh, I mean, yeah, that's weird. My CS class was auto muted, so I just assumed it was. That's my bad. Yeah.
Nope, that's all right. No worries. So just warning you before
Thank you. I
you start like
that.
talking and you say something maybe you don't want everyone to hear.
I got you. I appreciate that.
Not a problem.
Yeah, my headset's bad too, cause like if I look down at my phone at all, like that's when it starts catching my breath. So like.
Yep, I get you. Yeah. My headset's really sensitive, so if I hold it like just far enough away, like if I'm taking a drink or something and I forget to put it back, nobody can hear me, and I could be talking for days and no one will hear me. It won't pick my voice up.
Yeah.
Hello?
Hello.
Hello.
Hey guys, can you put on the videos? Do you have videos with you?
I don't have a webcam on my computer. I can get one though.
No, don't worry. No, don't get it for this. If you have it, it's nice. Is this clear enough? Oh, let's see. Is this readable?
Yes.
Travis?
Yeah, I can see it.
Matt? Feel free to put on the
Yeah, we're good.
Feel free to put on the camera. It's nice to have faces. I think we're only a few of us, so we should be okay. But it's not I'm not forcing. If you feel more comfortable with it, turn it off. Hey, yeah, nice to see you. Okay. Do you think I can write this small and you guys will be okay?
Yeah, it looks good.
Yeah.
Slightly bigger maybe.
Yeah, no, it's good.
This. So for those of you who are across virtually here, so first of all, I should introduce. I think all of you guys know me. Is there anyone who knows? Yeah, I think anyway. So I'm Shajish. And this is physics 320. Since I cannot pass on syllabus virtually, you get a virtual syllabus, and it is try to get on this website.com. Already there is trouble. No. Worked, right? This is not on SIU. Our physics server had some problems a few months back, and it is not yet up. So it's a long temporary solution. So it will be our website will be here, or the course website will be here for now. This should have a link to Physics 320, and on that you should have a syllabus and a homework. So get access to both of them while I distribute this here. Distribution of papers is all right. So for those of you who are on the other side, we have I think 2 students here. Will I be able to go all the way around? That's Wahid. And let's see how far it goes. I don't think so. I'm on. Too slow. I just make the settings properly. From both days, I will learn all this. There we go. Christian will just escape on both sides. Ah, here. It's Bowden and Christian. So there will be a Matt, Travis. It's writing, right? So 1, 2, 3, 4, 4 plus 3, 7 students. Yeah, very good. Yeah. Okay. So let me change this one. Okay, it's easy. Okay. And since we are only few of us, you don't have to mute yourself at other things. But again, it is nice if you have a lot of loud things going on in the background. You can mute it, but I'm not requiring you guys to mute or put off your video. At least from my perspective, it is useful to have see faces on the TV. Okay, so about the course, I hope we can still have a normal. As much normal as possible. Of course, even with these circumstances, at least last semester, even when, oh, yeah, no, that's okay. That's better than I thought that was. Yeah, so last semester when I was teaching this part 2 of this course, even with the course suddenly switching over to online, I think it went reasonably well. I could cover enough stuff, and with this system of a simple camera, I think we could achieve sufficiently. But hopefully, in these things get normal, maybe even during this semester after. But we'll try to do it as much as possible. It will be like this. Those of you are here, will be here, and those of you are not, these videos will be recorded. I mean, it's automatically recorded on Zoom. I set it like that. And the only thing I'll do is after, give me some time, and within a few hours, I'll transfer it onto YouTube. So this video will be available on YouTube. And if you're already on this website, you should be able to see a link to a YouTube playlist. So on that playlist, you see all of, as we move onwards, all the videos should be up. As of now, it should be empty that is coming on there. But it is manually done. So this video is recorded on the Zoom website. I download it from there and then upload it on on YouTube. It takes my laziness is involved in that. So, but usually I try to get it done in a few hours. So be patient about that. So with the lectures out there, and homework will be due preferably handwritten homework given to me in hand, but those who are virtually attending, you cannot. So I'll make a provision to upload it on D2L. So most of you probably have uploaded something or the other on D2L. So you should be able to upload it on D2L. I want scanned copies, a single file. Right? So preferably a PDF file, not 7 JPG files. It's just convenience. It's not a big deal. If it's once in a while, I don't mind it. But when you're dealing with 7 people and every week you have to do it, it's a little convenient if you send a single PDF file. You can use softwares like, what is it called? CamScan, I think, ask others. Get me a PDF file which has all the pages on it. If you want help with it, I can try to suggest certain apps, but ask your friends probably more. So, so that's about the homework. Then we have the lectures itself, and the important part is the exams. It gets hard to assess an exam online. So as far as exams go, you have to be present in the classroom. Is that possible for all of us here? Those are virtually there. So
all of us being present in the classroom for the exam?
Yes.
Yeah. Is it the same classroom or is it a different classroom?
Oh, we will make it this classroom as far as we'll need 2 classrooms. Most probably it will be the conference room, and the physics conference room will be used. We can accommodate probably 6 people here, 2 people there, and that should be sufficient.
Yes,
But,
I can do that.
Yeah, I can do that.
Okay, Travis and Curtis.
Yeah.
Yeah.
Okay, good. Okay, so that's mandatory. If by any chance you miss on that, I'll make provisions for that, but then it will become a makeup exam, and most of the things, regular rules for curving and other things do not go in the same way when it is a makeup exam. So, so it's best to avoid those circumstances. But so the only small restriction I put in is that the exams has to be taken physically in the classroom. And talk to me if there are adjustments to be made or any leniency on that side. But surely I won't be excusing that. We can make arrangements around that. That's the best I can. So that's something. Okay, so let's see what else. So website is that. Zoom meeting, yeah, all of you guys could log in. For those who did not try, the password for the Zoom meeting is IHBAR. So I think that's a mechanical term. So it's IHBAR, complex quantity HBAR, but it's actually so this is a password. So all of you guys tried it already. That just makes it easy to remember. What else? So the textbook for the course. So textbook. Other courses, Griffiths. Electrodynamics, the 4th edition. It doesn't matter which edition you go for, the content is mostly the same. 95% plus content is probably 98% of the content is the same. And as far as the homework questions go, I anyway type it and post it on the website, so that doesn't get affected. But feel free to get whichever edition. I'll refer to the 4th edition whenever there is a need for it. Griffith's textbook is, if you go by the number of departments all over the nation or all over the world that uses it, it's probably 90 to 95% of the physics departments at this level use Griffiths. So it's an extremely popular book, very standard. So it's good to get a copy of it if you want to be in physics. It's everyone recognizes the name, so it's good to read the book. It's good to use it extensively. So I'll recommend it completely. How much do I use notations wise? It will be, I might differ a little, but most of the content is same. How else should I say this? I don't go line to line as far as the textbook goes, so it is more of a reference than following line to line. You will see that when I'm going through the contents in my class, there might not be a one-to-one relation, but broadly speaking, there is a clear connection. So no doubt that textbook is the place to go, but at the same time, first go to the lecture and then try to build a connection between the lectures and the textbook. There are some reference books I can suggest. This is slightly advanced, but this is electrodynamics or classical electrodynamics. This is Stringer. Gerard. For authors, and you will see that this is a graduate level textbook, and as far as notations goes, you will see that at least I studied from this book, so I'm sure there is a clear connection there as far as notations goes, but still you won't see a one-to-one correspondence in there. So I'm not saying that, I'm not at all suggesting that you buy this book at all, because it's a harder book, it's a graduate level textbook. Griffiths is the textbook to go, but I've often heard from students that they find it is useful to connect it with my lecture notes. Again, it is up to you guys. So at least look into it for sure. Again, I would strongly suggest Griffith's book, at least reading it. By now, you should be able to connect in any lecture notes with a textbook, and that itself is a way of learning. So again, point is lecture notes and the textbook plays an important. The website I already said, there's a link on the website where you can reach the place or the course webpage. And something about evaluation, most of you probably have taken my course before, you might know how it goes, but still. So that'll be homework, which will be 30%. That'll be about one homework in a week Sometimes it's 10 days, but usually once in a week. So if there are about 10 to 12 homeworks during a semester, you get about 3% of your grade is homework. And there is what I'll call extra credit. And I'll tell you why it's extra credit, even though it is 5%. It used to be, if you have taken my course before, it used to be 0% before. Now I put it 5%, and I will tell, so let me call it y, right? So there's some variable y I'll use to evaluate that, and I'll talk about that a few minutes later. So, midterm exams. So this is exams. There will be 3 of them. It's the same as I used to have it. Usually just the percentage probably gets changed. Now it will be 15 into 3, so that's 45% of of midterm exam and the final exam. So this has changed a little bit. Earlier I used to have 40% of homework at least last year, and now I've put in more for the exams. Usually, if everyone is working on the homeworks well, putting in enough time on the homeworks, putting enough effort and time, then exams become pretty much like another homework for me. But if not everyone is putting in enough time on the homeworks, then I have to make an assessment on how much you're learning, and that's where I usually go for the exam. And typically, I've noticed that it is necessary to have an assessment with the exams also. I make it simple. It's usually doable within an hour, but at the same time, it is not trivial. So a good time spent on a homework helps in the exams. I think that's the way to put it. So exams are important, and another way I usually say is that if you have attended lectures in this course and you go home and you open the homework and you're able to immediately work on the homework, at least proceed with the homework. One is getting the solution, and the second is at least knowing what you could do, at least having one path to go with. That means you're doing good. At least you know what the question is asking, or at least you have one interpretation of what the question is asking, and how it is, how you could go with it. That is okay, but there is also a possibility that you attend the whole lecture and you go back home and you open the homework and you have no clue of what the question is asking and how you should proceed on that. That is not good. Then I would say that you should open the book, you should read the book, you should use the internet. That's all perfectly fine. You can talk to each other. But remember that you did not understand what the question was asking. That means you're missing something very big. You need to put a lot of effort in there. Meet me, or we need to talk in that case. That is another possibility, that you try to read the book, you try to read a lot of content on the internet, and after 4 hours of doing all that, and you still have absolutely no idea what the question is asking, or how you should write the first sentence, first equation down for the homework. That is not good. It doesn't mean that doesn't happen. It happens a lot in this course, but that's when probably you need to realize that there is a lot of work you need to do. So either meet me, or you need to discuss, or you need to reconsider your position in the course. It doesn't mean that you should back off. It's just that you need to realize that there's a lot of work you need to put into the course. Is that roughly clear? It's like sort of a self-assessment there. How much time you're needing, or how much effort, or how much extra resource you need for the homeworks is a measure of how much more effort you need to put in. So realize that. And if you have done that, then once you have finished the homework, you should be reasonably prepared with the midterm. remember that you can go to the internet, and especially on my own website, there are lots of solutions. Like there are websites. I make my old websites available on this page. So SPH. If you there is a link for old websites. So the old websites often have old lectures associated with it. Some of the homework problems might be exactly coming from the lectures itself. So often you can actually get a lot of help with the homework on my website itself. That's perfectly fine. Sometimes searching the question gets it. That's all perfectly fine. I don't mind it. But you should realize that you have taken help. That means you have skipped, you have used a shortcut. That means you have put in more effort into it. So that's one way of assessing yourself. Second is extra credit. What is extra credit? Let us say that after all this, including the extra credit, you got 60 out of 100. So that's a score, and typically the average scores in this course, if you go by the last 6 years or so, has varied between 40 all the way low of 40 and 80. So that's where the average lies. It is many people score 95 and above, but a lot of them score less also. So anywhere between 40 and 80. More recently, it has been 65 and 70. So it is not as low as I'm saying, but it could be. So let us say that someone gets 60 out of 100, and that's where extra credit comes in. It boosts your score. It is a way to curve the grade. And how do you do that is, what is extra credit all about? So during a lecture, I think again, some of you who have done it might know what it is. I might just randomly come up with reasonably random questions. Like, for example, I could ask, what is Maxwell's equation today? Right? So, maybe first. So, yeah. So, for example, I could ask a question now. Let us say this is an extra credit problem that write down or look up what are the 4 Maxwell's equations. Okay, so there are 4 Maxwell's equations, and the goal then is that you go and look up Maxwell's equation. But the question need not be as clear as I stated it now. Then what you have to do is you have to pose the question yourself. You have to ask what are Maxwell's equation, and go to Google and search immediately what are Maxwell's equation, and it comes up, and you read about it a little. This seems too straightforward, but it can be more interesting. For example, I could ask, is negative mass possible? Right? Mass, usually the way we see it, it's always positive. Is negative mass possible? And that might be curiosity. So you might go and ask, oh, is that really possible? And there might be few people who have said that, oh yeah, that's possible. And there might be some discussions on, no, it is not possible. So those kind of questions which do not have a clear answer. So you ask the question and you answer the question very briefly. Don't spend too much time on it. It's up to you how much time you want to spend it. But if you ask me, as far as the grades go, only for the grades, not for the motivation or learning purpose, as far as the grades go, I don't want you to spend more than 5 minutes. Okay, so this is just, and it's up to you how much you get motivated and you do it on your own. I don't want you guys to spend more than 5 minutes on one question. How do you give it back to me? Take a sheet of paper, just write down whatever you think it is. Even if you don't have an answer, just say that I tried, I did not get an answer. That's also perfectly fine. You will get full grades for that. And you upload it on D2L. Right? So usually you try to give it to me physically, but this one, upload it on D2L. Homework, you give it to me physically because I would really like to see through it. This is more of just to give you an easy way to give you points for a little bit of effort. And I've noticed that even this much of discipline, half of the students do not do it. So my goal is here is that, okay, you've gone back, open the textbook or open the your class notebook, and at least thought about what the lecture was about. And for me, that is, so that's a minimal requirement I'm putting in. And let's say each lecture had some questions. Even if there were no questions on extra credit, you still submit it saying that there were no questions. Okay, so there will always be a extra credit problem for every lecture. You have to know how many questions were asked. These days you have videos that you can go and look at, but it's not easy to go through the videos. At least I don't find it efficient. So what I suggest is that as the lecture comes, just make a small note in the corner of your notebook that that's what it is. Ask your friends, there's nothing wrong with that. What was the lecture? What was the extra credit problem? I don't want to take the effort and putting the questions down. Remember the questions itself, asking the question itself is part of the requirement. And after all this, let's say you got 75% of the question right. 75% of the questions that were there in extra credit, you got it. But again, I noticed that those of you who do it, they get full points because I don't grade them, assess them in a quantitative manner. It's just for participation. And those who do not submit it, they don't submit any of them. So usually either 0 or 1. But then I'll try to insist that try to make it, try to participate in it more. What happens is that this then becomes 0.75, like make it between 0 and 1. Now, how does this help? Your final grade, so this is your final grade, let's say, your points. So this is 60, right? So 60 plus, I'll try to give you back whatever you lost. So that percentage will be called A. So for example, I could give you 50% of it back. And of course, if A is equal to 1, everyone gets 100. But let's say you got 60, that means I'll give you 40, out of the 40 points you lost, I give you back 20 points. So that could be one. Usually in a real semester these days, it comes out about 20 to 25%. That's the amount of points I give back. But now where does your extra credit comes in? Even out of this 20 points, if you need it completely, you should have a y equal to 1. So I make that fraction in here. So if you don't have a 1 in there, you don't get back every point that you have returned back to you. So I feel that's a reasonable, fair way of curving. So those who have been reasonably disciplined with the course, that means to say that every day think about the lecture for a few minutes and find out what it is. Again, you can collaborate. I have nothing, no issues at all with that. You can ask the other friend, what were the questions, that makes it easier. In fact, that's a discussion that I would like to encourage. Right? What was the thing that was covered in the class? So that's good enough. So that's what it is. There are 4, the midterm, the next midterm exam is September 11th. So what are the things due? We have homework 1, that's due Monday. That's 24. August 24. Monday, and there is midterm 1, which is for this September 11th. I've set all the midterms on Friday. So every 4th week there is an exam. So on a Friday, 2 to 3 p.m. You guys will. If those of you, if you're not in the campus, if you're coming from far away for the exam, then I am okay. I am flexible, but for that, the whole class has to participate. And, I am okay with changing the post, but it has to be at least 2 weeks before the exam. You cannot say that I would like to postpone the exam 1 day before for some reasons like I'm not on campus. But flexible, but it shouldn't disturb the routine of the class. 2 weeks ahead, that's good. I guess that's all. Did I miss anything, or any questions you guys have? Anything at all?
I have a quick question. So could you please just confirm what grading scale you're going to be using? You do not put that in your syllabus or your website.
Oh, yes. So after that, it is a university scale. Once you, so this is, let's say I call it X prime, right? So this is X prime, is it is, right? So if X prime, still visible? Yeah. So if X prime is less than 100 and greater than 90, this is 8.
Okay, perfect. That's just what I was confirming to make sure you weren't doing a minus system.
Oh, A plus, A minus. Yeah. So that's something. Okay. What I do is that I'll go by A, B, C, D. That's what I've noticed most of the students prefer. But at the end, if I feel that someone is gaining out of it, I won't use the plus or minus against the student. Sometimes it can be used to make a student's grade better. So it can be used for the benefit of the student. Is that clear what I mean?
Yeah, absolutely. I was worried about the minus system because a couple of my classes are using it. So you have to get a 94 or higher to get an A, not just a 90.
I'm not using that. I'm not using that. So, but sometimes I can use that, right? For example, is there an A plus? There is no A plus, right?
No, but
So
there's a B plus, right? If you get like 89%. So I understand what you're saying.
sometimes I feel that B plus is better than B, or even B is better than B minus. So B anyway you get. So I use B plus and all. But that's at the end of the course. Only if I feel strongly about it. I've used it more than it's only I think 2-3 semesters that they have started this, and I've already used it at least once in each semester. So, but it's always for the benefit. It only helps the student. It never hurts the student. If that, I think that answers the question, right?
It does. Thank you.
So, yes. Any other questions? Okay. And how does these online things go for you guys? Does it have any connection problems?
No, I actually really prefer this. It's been very helpful in my personal situation.
And it smoothly goes in, right? Like
Yeah,
connection problems and all.
it's perfect. No delay. No, it seems great.
Yeah. No, this was good. Yeah. Okay.
Yeah, I was like today I just used the D2L virtual classroom and it was having problems. Like some student like me, my sound was static and so the professor is gonna use Zoom. And then another class was Zoom and it was I think it was just a better user experience.
Okay.
Yeah.
Yeah, I did not have any serious issues last semester when we used it, and in the summer also we used it extensively, and it seems to, and that is from my house into this should be much better, I suppose. But again, but that's where the recordings comes in. I think it should be. But I was curious how this. What about others, Matt? Has it been good? The connections you muted. I think in other classes you require them to be muted. So, oh, I guess there's a connection problem already. You guys can hear me?
Yeah.
Yeah.
I can't speak.
Yeah.
Oh, okay, yeah, you can. Okay. Yeah, I thought the connection was lost. I thought he just now said good things about it. Okay. Okay. So, yeah, let me know if I can be of any help or anything for those of you who were should be attending.
And that's the thing, like with Zoom, you don't really need like a high speed internet. You know, you might need like, I don't know. I mean, I guess it just depends if there's a lot of people in your house using the internet. I know like there's a internet provider called Frontier and they have pretty bad internet, but I think people with MediaCom or something else might be fine.
But university should be having an exclusive, like its own line, I suppose. Yeah. Yeah, but I think on the other end they will be having. But yeah, let's see how far we go with all this. Okay. So let's So we have how much? 10 minutes, yeah. So let's try to do something. Yeah. So let's at least write down one Maxwell equation. So one of the Maxwell's equation is called Gauss's theorem. Gauss's law, I guess. And anyone remembers?
Divergence of the electric field, or is equal to the charge.
Good. So one of the Maxwell's equation, we will use differential form more here, but I'll write down. So this is a gradient operator. Is that a familiar thing? Gradient operator?
Yes.
All of us should be. So this is, let me write it somewhere here. The gradient operator in rectangular coordinates is this. But we would like to start having a feel for the gradient operator without this specific coordinate representation. We should have we should try to build an idea of what a gradient operator is on its own. So it's a differential operator, acts on a vector or a scalar. When it acts on a vector, this is called a divergence, and we'll talk about that in the next these weeks. Electric field is R, T, like it can depend on both position and time. It's there everywhere in space. It's a vector field, and this is equal to how many of you are familiar of this equation? Is it readable on the across the virtually?
Yes. That's an epsilon in the bottom, correct? In the denominator?
Yes. So let's give it
Yeah,
name.
no, as long as that is, then yeah, I can read it.
Do you see the epsilon not to 0?
Epsilon. Oh, not epsilon 0.
Yep.
No. Oh, you can see it. Okay, I was just wondering.
Of vacuum. How many of you have seen this equation before or used, let's say?
That's like from 205B.
205B. Do you see this equation? 205B?
Oh, no, the epsilon not.
Oh, epsilon not. Yeah, but this equation you don't see in 205B, correct? Or do you?
No, I don't think I've seen it yet.
Maybe at the very end you would see it, but typically it is done in passing. So we need to think about that. What is rho, by the way? So it's charge density. So this is charge density, like we have mass density, we have charge density. It is basically charge per unit volume. We'll talk more about it, but this is just in the last 10 minutes. I want to give a little bit of introduction in a sense. So you guys are not seeing this equation, but you guys have seen Gauss's law in integral form. And what is that equal to? How does Gauss's law look like in integral form?
The divergence of a volume is the same as the flux through the surface.
Yeah, but how would you state it? Yes, yeah.
It's like the triple integral of a divergence, or divergence of a triple integral. No. A triple integral can be expressed as a divergence over a surface integral.
Yes. But you're saying the divergence theorem, Gauss's law.
Okay.
Now you're correct. I'm thinking very correct. I'm not discouraging you, but I want a statement, final statement. They're trying to prove it. It's good.
Maybe not.
Anyone else?
I thought it was a double integral.
Yes, that's correct.
So the integral over a volume is equal to the divergence of a surface integral. That no.
Roughly.
Close.
Okay. Okay. Let me say so So this is how you have probably seen it. So this is a surface integral. Right? So that means there are two integrals in here. Okay. Dotted with electric field. So if you do the volume integral here, you get this. I think that's what Christian you were trying to do. If you do the volume integral here, you get this. So let me just write electric field, just not to have too much clutter. It's basically it has R and T difference here. And if you do that, so this is got by divergence theorem and integral. If you do the same thing here, you get charge. But it's a charge enclosed in the volume. So this is a surface integral about a volume. Is that familiar?
It is familiar.
It is familiar? Good, thank you. Right, so this, all of you guys should be familiar, otherwise just at least look up what it is about. We will of course do these things, but it's this is from Children. What does it mean? So let's see what it means. So let's take a positive charge, right? So let's say there is just one charge in the whole universe. That's how it is. And we know the electric field for a charge. What is the electric field for a point charge? What's the electric field for a point charge?
4 pi q or q over 4 pi.
Q over r squared. So it is proportional to the charge q, inversely proportional to r squared, right? And we will be working in SI units. So there is a 1 over 4 pi epsilon naught. And talk about units. Units have some issues in electrodynamics. Half of the textbook use 1 unit, half of the textbook use another units, and equations look different in different units in electrodynamics. Remember, when you're doing Newton's laws, whether you use meter or feet, your F equal to ma equations don't change, right? Equations remain the same. You will not say that F equal to ma is something else in this unit. Equation remains the same. It's just that how you evaluate the numbers change. But in electrodynamics, the equations themselves change. So when you're going from one book to the other, it is very hard sometimes for a beginner. Right? You will go to one book, there is some extra epsilon sitting there, in another book there is no epsilon sitting there. So for example, half of the textbook will say electric field is this one. That's perfectly correct in some unit. There is no 4 pi epsilon. In fact, all the engineers use SI units. That's predominantly all the engineering textbook use SI units, and all the physics textbook use what is called Gaussian units. But here in this class, we will use SI units. So there will be this 4 pi epsilon. And you'll notice that's just a number, that's a constant, right? It will keep sitting there. So often it's considered a clutter. There is not much physics in there. But when you're evaluating numbers, it does matter. So it's important. So we will try to keep it. So again, electric field is proportional to charge, inversely proportional to r squared. So if you were to plot it, it gets weaker and weaker as you go farther and farther. So this is how the electric field looks like. That's one way of. So this is. These lines are actually a visual representation of that equation. What does it mean? The charge Q is how much charge is there, but there is an inverse proportional to R squared. Notice that the lines, if you were to take a fixed number of fixed volume, the amount of lines that cross that volume. So the density of these lines is a measure of how strong the electric field is. There are more lines closer to the charge than there are away from it, relatively speaking. You can draw as many lines as you want, so that's not a way to do it. But once you've drawn the lines, you will see that there are more lines closer to the charge. That means it is stronger. The electric field is stronger near the charge and weaker away from that. Now, what does this mean? What does Gauss's law mean? Now, choose any closed volume. So this is a volume. Okay. And this volume will have a surface, that's ds. Like that's a normal to every small element. That is a surface vector, and the electric field is in this direction, right? So this is your normal, that is your electric field here. And you take the dot product, they need not be aligned all the time. You have to do this for every point on this volume. Right? This is the volume, so you have to close it and add up all those quantities. That seems like a lot of work, right? You have to actually evaluate this for all this volume. What will that volume be equal to? So this particular volume that I've drawn, how much will this whole integral be equal to? So Christian says it will be 0 because there is no charge enclosed. The right hand side says that it is a charge enclosed, but there is no charge enclosed, right? Because there is only one charge in there. So even though that integral is very hard to do, the answer is very simple. You don't even have to do it before doing the integral. You can do the answer, it will be the integral. For that matter, for any volume, that will be 0, except when it actually encloses this charge itself, and then you know that that's going to be Q. So that's the idea of Gauss's theorem. But now let's make this, let's go to this differential form, right? That's the electric field again. Let me ask you again. So this is at a point, that is no volume, right? This is at one point. So I choose this point to be here. That's a special point. I choose that point and evaluate this divergence of the electric field. I know the electric field, how much it is, it's 1 over r squared. I evaluate the differential operator on that and calculate del dot E at this particular point. How much will that be equal to? Let's say this is 3 meters away from the charge. Put in as whatever number you want to. How much will that be equal to?
I'm sorry, could you repeat the question?
So for a point charge, there is electric field everywhere around. Right? That electric field expression is this.
So
I evaluate divergence of that electric field and evaluate it at a particular point, which is 3 meters away, somewhere away from the charge, let's say. And my question is, what is that equal to? What is del dot E equal to? Or the divergence of the electric field equal to at some point away from the charge? Yes, Riley, you got a question.
no, sorry. So the electric field would be 1 over 36 pi E naught, right?
Yes.
But so when you take the dot product, though, doesn't it cancel out? Like, doesn't it set it to 0 because it's not? There's no change. There's no change in position.
This is 1 over r squared, right? There is an r here in it. Like, you don't put in the numbers first, right? You have to evaluate after taking the derivative. Right?
Okay.
So, is that clear what I said?
Yeah, just trying to figure out how to do it.
Yeah, but the answer is simple. See, notice when you were doing the integral form, you wanted to look at the right-hand side. Left-hand side is too much work. You won't get anywhere there. Right-hand side has the answer, right? Look at the right-hand side. Left-hand side, of course, should be equal. It's a law. But what is the right-hand side at this point? 0, right? Because that's charge per unit volume. There is no charge there. Right? So divergence will be 0. For that matter, it will be 0 everywhere. Except at the point charge. This quantity is 0 everywhere. Okay? So that's going to be the most important concept you will learn in the whole semester. Okay? It sounds very simple, but it's 0 everywhere. And what will it be at that point? What will it be equal to at that point? Charge per unit volume.
You have to calculate like the volume of the proton, or
Yeah, but it's a point charge, they said.
It's infinite.
It's infinity, right? Charge is 0 and volume is pretty much a point charge, so I can take it to 0. So that's infinity. So the divergence of the electric field is 0 everywhere outside the charge. On the charge is infinity. Okay. Now, what I want you guys to do, this is the extra credit, right? So I've already crossed the time. Evaluate the left hand side. Is it really 0? Check it out. Just evaluate it. So that's extra credit from. Attempt on evaluate this explicitly. Try to evaluate it. Probably I teach you the techniques and all that, but that's so this is the content of this will go on for a few weeks at least, and we'll only expand on this more and more. That's all. Thank you. Any questions, comments? How many of you have classes after this?
I got one more, but I have an hour.
Oh, you have an hour. Okay. So, you're all right.
I'm done for today.
I think those who are online, I think they can just click and reach, right? Okay, guys, enjoy. Muted. So.
Need help with anything?
I think I'll manage. I think I have to manage. I'm trying to